Hi class, welcome to another video lesson. On this particular lesson, we're going to talk about solving systems using the process of elimination. We've already talked about solving systems using graphing and using substitution, and so this will be our third and final method of elimination. So what elimination is when you think of the word eliminate, hopefully you think of maybe getting rid of or erasing or something like that. When we want to eliminate a variable, we want to get rid of it, or we want it to disappear. So the way that we do that is we add up our variables, add up our x's and add up our y's. And if we want one of the variables to be gone, we got to have a positive integer and a negative integer that are the same value. What I mean by that is 6 plus a negative 6 is 0. Now it's eliminated. Or if we have 15 minus 15, obviously that is a 0. It gets eliminated. So what we want here is we either want the x's to disappear or we want the y's to disappear or eliminate them. So if we want one of them to be positive and one of them to be negative, it just makes sense that let's get rid of the y's. Why is that? Because the 3y is positive and the 2y is negative. So we already have a positive and negative pair. So all we have to do is get this value and this value to be the exact same. So I'm sure that you guys have been introduced to this before, and hopefully you are familiar enough to be very good at this. You would say, well, I want to get each of these to be 6y. If that's the case, I'm going to multiply this whole thing by 2. And now I'm going to distribute this 2. 2 times 2x is 4x. 2 times 3y is 6y. And 2 times 12 is 24. So I successfully distributed that 2, and the reason for that is because I wanted to get a 6y right here, which as you can see, I do. So now let's get a negative 6y here. And how would I get that negative 6y? By multiplying everything by 3. So we're going to distribute this 3 to all three terms. 15x minus 6y, that equals 33. Continuing to solve now. Once I have these two pairs, one's a positive 6 and one's a negative 6, I know that I'm ready to eliminate a variable just by adding. So I'm going to add up all of these columns. Add up this one, add up this one, and add up this one. So we have 4 plus 15, that would be 19x. A positive 6y minus 6y, that equals 0y, and that was our intention. So our goal has been met. So now we have to add up the right side. 24 plus 33, that is 57. And now, this is a very basic equation, solving for x. Let's divide both sides by 19. 57 divided by 19, x equals 3. So now, never forget, you're solving for both variables. You've only solved for one, you solve for x. So now let's solve for y. It really doesn't matter which equation you put it into, you're going to get the same y value regardless. So it really doesn't matter. I'll put the 3 that we got for x into this one. 2 multiplied by x, which we said x equals 3. Plus 3y, that equals a positive 12. Solving 2 times 3 is 6. Plus 3y equals 12. Subtract the 6. 3y equals 6. Divide by 3. Y equals 2. So you have found your answer. X equals 3 and y equals 2. But remember, these are two lines that intersect at one point. So let's write that point in an ordered pair. 3 for the x and 2 for the y. So this, class, is our answer. And like I've said before in graphing and substitution, you're more than welcome to check your answer. All you have to do is put your x and y ordered pair into this one and put your x, y ordered pair into this one. After doing this work, you should get 12 equals 12 after doing this work, you should get 11 equals 11. And that's how you can know for certain that you have the right answer. All right, you guys are up. Let's try number 5. What I want to happen here, and please follow directions. I know that I'm not going to be watching you to make sure that you follow these directions, but I just want to prove a point. I want guys, if you are watching this video, I want you to eliminate the N's. If you are a girl watching this video, I want you to eliminate the A's. Okay? And let's just prove that it doesn't matter which variable you get rid of. You can get rid of the N's or the A's first. It doesn't matter. You're still going to get the right answer. So girls, why don't you go ahead and get rid of, spelled that wrong. Why don't you go ahead and get rid of the N's? Wait, I said guys, right? Boy, I'm losing it. Okay, guys, you get rid of the N's. Girls, you get rid of the A's. Okay? And we will see if we get the exact same thing. All right. Guys, here's what you should have gotten when you got rid of the N's. You should have multiplied this one by a -3. If you were to do that, that way you would get this to be a -6n, which would cancel out with this 6n. So when we multiply this, we get a -6n. Distribute the -3 to 5a to get a -15a. And the -3 to 14. A -3 times 14 is a -42. So now these are our two systems of equations. So all we're going to do is we are going to add them. So we have 6n minus 6n, that is 0n. The n's have just been eliminated. And now we have a -8a. That equals a -32. So then dividing by a -8, a would then have to equal a +4. A equals 4. So now let's substitute that a in for, we'll go to this equation. 2 multiplied by n plus 5 times a, which a equals 4. That equals 14. 2n plus 20 equals 14. 2n equals, after subtracting the 20, you get a -6. So n equals a -3. There's your two variables. A equals 4 and n equals a -3. In class, in this case, you could just leave your answer like this. A equals a -4. Oh, a equals a +4. And n equals a -3. You don't have to write this in an ordered pair. Just if you get x's and y's, leave those in ordered pairs. Obviously, a's and n's, we don't leave those in ordered pairs, so you can just keep it as a equals and n equals. All right, girls, let's do your work now. You eliminated the a's, so 2n plus 5a equals 14. And we got 6n plus 7a. 6n plus 7a equals 10. Girls, you had the harder one on this one. You have to somehow get these two variables, a, to be the exact same coefficient except one of them's positive, one of them's negative. So I would recommend multiplying this whole one by 7 and multiplying this whole equation by a -5. That way you'd get one to be a positive 35a and the other one to be a negative 35a. So let's do the top equation first. 14n plus 35a equals 14 times 7. I don't have my calculator on me. 98. Now we're going to distribute that -5. So we have a -30n minus 35a That equals a negative 50. Okay, and as you can see, the a's have been eliminated, thus elimination method. Over here we have a negative 16n. That equals a negative 48. Dividing then both sides by a negative 16. A negative 48 divided by a negative 16. N would then equal a... Did I do something wrong here? Rats, where did I go wrong? N would then be a positive 4. And I got A to be a positive 4. Sorry about that, class. I don't know what I was thinking here. 98 minus 50, that's a positive 48. There we are. And then we have a positive 48 divided by a negative 16. That would mean that n would have to equal then a negative 3. Which is the exact same thing that we got back up here when the guys eliminated the n's. N equals a negative 3 right here. So as you can see then, we would then get n, or a, to equal a positive 4. So it doesn't matter which variable you eliminate first, you're going to have to solve both of them to get n and a anyway, so it really doesn't matter which variable you get rid of first. All right, I have one more video to record, and that's just a couple of these tips. But remember, for homework, you're going to have objectives 21, 22, and 23. Be sure to let me know if you have any questions on substitution, elimination, and graphing when you get to class tomorrow.